Hey guys, welcome to Using Algebra to Solve Word Problems. We're going to be working on set 1, finding two numbers. But before we do that, let's talk specifically about the steps that you're going to take to solve these word problems. Step 1, you want to define a variable. So when I show my work, I'm going to be using let statements to define my variable. You will also be doing the same. Step 2, after you've set up your let statements and you've set up your variables, you're going to set up an equation based on what the story problem says, and you're going to solve that equation. And after you've solved your equation, you're going to look back at your let statements and you're going to define your answer. You're going to give exactly, in words, what the problem is asking for. So let's take a look at number 1. The larger of two numbers is 4 more than the smaller number. If the sum of the numbers is 74, find the numbers. So I'm going to grab my let statement from the first sentence. The larger, there's two numbers, the larger one is 4 more than the smaller one. So we have a larger and a smaller, which means I'm going to need two let statements, one for each unknown. So I'm going to let x represent my smaller number and x plus 4 represent my larger number, because the larger was 4 more than the smaller. So I put it all in terms of x. Next, I'm going to set up my equation. Well, that's going to come from the second sentence. If the sum of the two numbers is 74, find the numbers. So my small plus my large equals 74, which means x plus 4 equals 74. Now that I've set up my equation, I'm going to solve my equation by combining like terms and then isolating. And then if I divide by 2 on both sides, I get that x is equal to 35. Now that I've solved, I'm going to define my answer. Well, let's look back at our let statements. Since we just found that x is equal to 35, we found x, which means we found the smaller number. So the smaller number is 35, and the large number, which is x plus 4, is 39. We could obviously check our work by making sure that the smaller and the larger are 4 away from each other, and that the smaller plus the larger makes 74. So let's take a look at number 2. It says the larger of two numbers is 7 less than 3 times the smaller number. If the sum of the numbers is 61, find the numbers. So we're going to use this first sentence to create our let statement. So let's let x equal the smaller number. And let's see here, we've got the larger is 7 less than 3 times the smaller. So 7 less than 3 times the smaller, and that's going to be our larger. So we have our two let statements for our two numbers. X is the smaller, 3x minus 7 is the larger. And it says the sum of the numbers is 61. So I'm going to take my smaller, add it to my larger, and make 61. Now we're ready to solve. So we combine like terms and do the two-step equation to find that x is equal to 17. Take this back to my let statement, and I just found my smaller number. So 17 is my smaller number, and then I'm going to go ahead and plug 17 right in here for x to figure out what my larger number is. 17 times 3 minus 7, that's 44, and that's our large number. Again, you could check your work by making sure that the sum of those two numbers does make 61. There we go. That the sum is 61 and that these equality statements are true. I'm going to jump over to number 4. Number 4 is a little bit different, but we're still going to create the let statements. So let's read the problem first. The larger of two numbers is twice the smaller. If 12 is subtracted from the larger, the result is 7 more than the smaller. Find the numbers. Notice how this one didn't say anything about the sum of those numbers. This was a little bit different. So let's take the first sentence and let's build a let statement. We have two numbers, so we need a variable for our large and an expression for our small. So the larger is twice the smaller. Larger is twice the smaller. So let's let x equal the small, and the larger is twice the small. So let's make 2x equal the large. So that all came from this first statement. The larger is twice the smaller. If we call x small, and we have to call 2x large. Now in this next statement, if 12 is subtracted from the larger, the result is 7 more than the smaller. That's going to be our equation. If 12 is subtracted from the larger, then the result is 7 more than the smaller. If 12 is subtracted from the larger, then the result is 7 more than the smaller. Now we've built an equation, now we can solve. So I'm going to start off by zeroing out this x on the right side by subtracting x from both sides. X minus 12 is equal to 7. So x, adding 12 to both sides, x is equal to 19. Go back to your let statement. We just found the small. So 19 is the small number, and 19 times 2, which is 38, that's the large number. The last question from set 1 that I'd like to do together is number 8. Number 8's a little bit tricky, so let's read it slowly. There are 10 less red Skittles than orange Skittles in the bag. The orange Skittles are also twice the number of red Skittles. Find the number of red and orange Skittles in the bag. So in the first sentence, it says there are 10 less red Skittles than orange Skittles. So let's go ahead and let's choose orange. Let's let x equal orange. And there's 10 less red than orange. So there's more orange. And if we take the amount of oranges and take 10 away, we'll get the number of red. So then red must be orange minus 10. If we would have said that x was red, then orange would be x plus 10. So it doesn't matter who you call, okay? Who you call x. But I went ahead and called orange x, which means red is orange, take away 10, according to that first sentence. The second sentence says, in the same bag, the orange Skittles are also, because it's in the same bag, the orange Skittles are also twice the number of red Skittles. So the orange, x, equals twice the number of red Skittles. The orange Skittles are also twice the number of red Skittles. So here's orange, here's twice, and here's our red Skittles. So if we take that equation, x equals 2 times x minus 10, and solve by following the correct multi-step equations, okay, so we distribute the 2. Let's zero this 2x out. I get negative x is equal to negative 20, which means x, if I divide by negative 1 on both sides to get rid of those negative signs, x is equal to 20. I look back at my let statement. I just found the amount of orange Skittles. So there are 20 orange Skittles. I cannot spell. There we go. Orange Skittles. And 20 take away 10. 10 red Skittles. There are other ways you can set up this equation. But this is probably the easiest if you're going word for word on that second sentence. The orange Skittles equal twice the number of red Skittles. That concludes word problems set 1.